So here, students, I'm making a short video on how to find the equation of a planes in a vectors form or scalar form and a general form. What I did take is equation of a plane. Now, in a three-dimensional space, I'm just taking this cardboard is a flat surface area, and this plane, this whole flat surface is called a plane, and you can see I can just move around anywhere. So anywhere in space, it always will be represented by x, y, and z. So we want to know what is that equation in terms of x, y, z, because each point, let's see if this is the tip of the point, it will always have x, y, z, right? Like from the x-axis, from the y-axis, and from the z-axis. So now, what I did is just to save my time, I already have a chart here. So just imagine that this is the plane right here, and I did take 2 points here. Let's see. This is the point I took as x naught y. So this is the given point. So the p naught. So the p naught is given. So this point is given to you on the plane. P naught is given, and I will call it as let's call it as p. P is x naught, y naught, and z naught. This is given to you. Then there is also one more thing, is there is a vector that is given to you. So it means the plane. Now, how do we determine a plane? If you have a point right here, so let's see, if I have a point, so this is a point, then the plane can move around, hover around anywhere, see? So there will be various planes, they go to the same point. But the moment if you have a point, and then let's see, if this is a point P, let's see, yeah, let's take this as the point x naught, y naught, z naught, and I can have a vector like this way, which is normal vector. Now what is normal is perpendicular. Watch this. So now let's imagine if there was a point right here, for this point, x1, y1, z1, and a vector which is perpendicular, then this determines a unit plane. So knowing the point and knowing the normal vector, we can determine it fixes a plane right there. That's it. You can't move it. Of course, it can move this way also. Then the whole changes. But what is seen is used is a fixed plane. It's like how we have. How do we figure out equation of line is what we need to find equation of a line. You need to have a point here, and there should be some rise over run. See, this is the run, and this is the rise. So the point should be there, x1, y1. So if we know these two things, we can find point y minus y1 equals m is x minus x naught. So I'm using the same idea here is, so given a point P, which is x naught, y naught, z naught, so there is a position, this will be r naught will be a position vector. So your r naught here will be is x naught. These are the component of r. When that p be this. So if you have a p which is a fixed point, then the r could be anywhere on the plane here. So that is that is taken as this one. I'll take it as p r t, and this is p. Okay, so this is p, and that is r. So the r is let it be any point. So in the component form, we say, okay, this is the vector becomes equals x, y, z. Okay, so now there's a green vector. So this is a green vector. This is like a r bar, and it is maybe represented by, I'm going to write down, there is a normal. Let n represent the normal vector with the component a, b, c. So it will always have, I can draw this green one right here. I could draw. So this green one could be also the same thing. It is perpendicular, as long as it is perpendicular. So if I from here, then it is represented by a, b, c. So I draw it here. So this vector is the green color vector a, b, c here. So this is a, b, c. Now the next is how do we find now, because so here it is. this is the P, this is the P, this is the P, and that's the R. So from P to R, you have a vector on the plane. So again, so P to R, there is a vector, and this vector we need to find what is this vector, right? So this is R vector, this is R naught vector. So you want to find P to R. So from here to P to R, we can write P vector R. So these are the vector form of R is x, y, z, and this is x naught, y naught, z naught. So you have to just subtract. So it is x minus x naught, y minus y naught, and z minus z naught. So that is PR. Now this PR is perpendicular to the normal vector R, and because they are perpendicular, the dot product is 0. So by dot product, definition or definition, that is, if this is 0, because how we define this is A, B, and cosine of theta, right? Now theta is 0, cosine 90 is 0, so you get whole thing is 0. So that's how we are going to say, okay, PR is this, so that PR is this one. One more thing I wanted to show also is PR is also, because it is R here and this is R naught, so this vector P to Q, so P to R, so this is R, so P to R, you have to start the tip of this vector, so the tip of the vector P to R is R. So I have to take this is also R, because we want to write in the vector form. So two things, one is the vector form and another one is scalar form and general form. So R minus R naught becomes equals, so E is perpendicular. So it's the same thing I'm writing. Okay, so let me, by dot product, so by dot product definition, so now what's going on is your PR, so this part is, see this? So x minus x naught, so this x minus x naught, so this is like your component from this, and this is getting multiplied, see this too? So it will be, so it will multiply A times, so the green one, so that's A times plus B times this one, y minus y naught, and plus C times Z minus Z naught. And this is called, so just write down, this part is called a scalar form. And then I'm going to use the distributive property. So if you use the distributive property, you can combine this AX, then this BY, AX, then this BY, then this CZ, we can put them together, and then you can use the other one. Let me use A times this one, so that's minus AX naught, and this one is minus BY naught, and this one is CZ naught equals 0. So we can write this as AX plus BY plus CZ, and this can be written again. I'll combine as a minus here, so I'll call this as minus, and you can also call it as D. So does D stands for equals 0, and this is called, when you write like this, is called general form. So what is general form is that D stands for, so this D, because all of them are minus, so this minus, I can write just a single minus, and then write AX naught plus BY naught plus CZ naught. So that's how it is. So just wanted to show that which one is this is a scalar form, and when you write like this, that's called a general form. So we'll take two examples quickly. And then what is the vector form? So the vector form is the same thing here. Let me make my, so let me write vector form right here. So the vector form is r minus r naught, which is, because it's perpendicular, this dot n cap equals 0, right? So now we can write this as this dot product by algebra of dot product. This is say distributes minus equals 0, and then we can write this also as by adding, because this is like a number, because you're doing a dot product is a number, right? So you can do both sides, which is r and equals r dot n cap, see? And this is the vector form. Only thing I missed here, r naught here, right? So this is the one that you already know the point. So this is the dot product, and that's it. So basically r is nothing but x, y, z, and this is a, b, c, and this one is r naught, that is x naught, y naught, and z naught, and this n cap is a, b, c, and done. So just wanted to make sure we understand that. Yes, what are we supposed to remember is only, okay, that's the scalar form, and when you write like this is called the general form, and when you write this is vector form. Now here I have one problem. एक स्टूडेंट है तो मास्टर को टिकट पर काम दिखाने का बराबर. So as one example before I show this, just one example to show, maybe one or two. There's a question is asked: find the equation of a plane. So let's say this is a plane and it has a point. So the point is given to you. So this is x naught, y naught, and z naught, and it's a parallel to another plane. So there's another plane. So let's imagine. Can you think of? So this is a plane, this plane, and this plane contains that 362, and it is parallel. So they are like parallel, like see. So that means this one, whatever that is given to you, this is given. So whatever the given one, so I can write this in the, remember whatever that multiplies to this, those ax, if you see this ax, by, this a, b, c are the coefficients. So the normal vector is nothing but a, b, c, and that in this example is just 2, 3, and minus 1. Here there is no number to z, is 3 minus, so it is 3, 2, 3, and minus 1. See, that's a, b, c, you already know. That's it. And the moment you have this, you just use this, because the normal vector for the given plane is the same as whatever. So you want to figure out what is the equation of this plane, but this plane is perpendicular to this one. See, they are parallel. So whatever the normal here, whatever is perpendicular right here, this one, it will be the same for this one. So I'm going to use this. This is going to be used for the planes to that one. So the equation becomes x minus. So the equation in general form is this. And then you write, okay, it is a is 2, so it is 2. So it is 2 x naught is 3 plus 3 times y minus. So you just plug in those x naught, y naught, and then y naught. Actually, this is 6, right? I'm doing it fast. And this problem, I'm going to do another video on this. I just wanted to show only one example just to get an idea. Okay, this part is hmm, is the c is -1, so that's like I can write directly -1, and y minus z naught is -2 here. -2 and -2 I can write +2 equals 0, and then you work it out 2x. Okay, so this becomes 2x plus 3y minus y, and this becomes -6 minus 18 and -2 equals 0. So you get 3x plus 3y minus y. So this is the scalar form. And that's the general form we are writing, and so this answer becomes, this will be 18 into -26 equals 0, and you're done. So that's the general form. If you want to write the vector form is this one. So you're just multiplying the r bar to n equal the same one to the point to n. So it means here you can write your r bar is x, y, z, and this is a, b, c is 2, 3, 1, 2, 3, 1, and this one is the same as you are multiplying. How you get -26? You can do the same thing. So this is going to be -26. -26. That's it. I just want to make sure it is. Did I make a mistake here? Yes. So when you're multiplying this to this, you're multiplying this point to this one, right? So it is like 3 times 2 is 6. 3 times 2 is 6. Then 3 times 6 is 18, and then minus plus 12. Oh, that's 26. So this is plus 26 because you're going on the other side. That's why. So on the left side it is -26. On the right side is done. Okay. So as I say, I'll make another video where we will want to show more problem solved. This is just one example. You can have a plane containing like 3 points will be given to you, or they'll be giving 2 points and a vector and a line on this one, or you can give one plane 2 points and another plane which is perpendicular to another plane, like say. So something like this. So 2 planes intersecting and what's going on. So we'll see this in the next video that I'll make. Thanks for watching, and hope this helps. I did go fast, but just wanted to know how do you find the equation of a plane? From where did we get that? How did we get equation of a plane? Okay, thank you. See you. God bless you.